Hello everyone, in this video I'm going to be showing you how to find the modulus and argument of a complex number. So, if we have our complex plane and we have this point here, 3 plus 3i, we're going to find the modulus is going to be the absolute value or the distance from 0. And the argument is this angle here, or if it's below, it's going to be that angle there, and it'll have a negative argument. So, we've got 3 plus 3i. Let's find the modulus. So the modulus, using Pythagoras, if we can imagine this as a triangle here, with this being one side and this being another side, we can just take the square root like this. We can do the square root, because this side here is going to be 3. That'll be 3i, and that will be 3. So it'll be the square root of 3 squared plus 3 squared. It's going to equal the square root of 9 plus 9. It's equal to the square root of 18. And if we just put that into our calculator, we can see that's going to be, or we can just work this out actually. That's going to be the square root of 9 times the square root of 2. So that'll just be 3 root 2, because the square root of 9 is just 3. So that there is the modulus. Now the argument, let's find the argument. So arg, we'll call this number here z. So argument of z is going to equal the tan inverse of the imaginary part, or 3 over 3. It's just going to be the tan inverse of 1, because we can simplify that, is equal to pi on 4. So, there we go. We just found the modulus, which is 3 root 2, and the argument pi on 4. Now, if we were to write this number in polar form, that would be 3 root 2 outside of cosine of pi on 4 plus I times the sine of pi on 4. Now we have to remember, always use radians. What if we were to do another number? I'm going to put it up first, you guys can figure it out, and then I'm going to work through how we get there. That there is your new number. Okay, we'll call that z. Now what is the modulus and argument? You can pause the video, try and figure it out, and I'm working through it now. So we can remember that the modulus, this is how we write it, like the absolute value, the distance from 0, is going to equal the square root of 5 squared plus 3 squared. Now the argument, so because of that, we know that this distance here is the square root of 34. The argument, or this angle here, is going to equal the tan inverse of the imaginary part, so 3 over 5. It's going to equal, it's not going to have a nice number, but we'll just do that to 2 decimal places. There we go. So now, writing that in polar form, we would get the square root of 34 outside of cosine of 0.54 plus I times the sine of 0.54, just like that. Let's do another one. What if this number sits in here? What if it's here? So negative 4 minus 3i. Let's denote that as z. So we'll say z equals that. Let's find the modulus of z. That's just going to be the same. That'll be the square root of the absolute value of 4. So we can just put in negative 4, because the square of a negative number is the same as the square of the positive version. But we can just put in negative 4 squared plus negative 3 squared. And it's important to use brackets when doing this, otherwise your calculator can get confused. So that will just be the square root of 16 plus 9 equals square root of 25 equals 5. And the modulus, we always take the positive side, because you can't have a negative modulus. Now the argument of z is going to be, you can look at that for a little clue. Okay, I'm working it out now. Tan inverse of the imaginary, so negative 3 over negative 4, is just going to equal the same as the tan inverse, because it's negative and negative, of 3 on 4. We need to remember that the tan inverse of 3 on 4 is going to give us this angle here, if it's the opposite. If we were to have a reflection of this, it's going to be like there. It's going to give us that angle there. But we don't want that. We want the angle, that one there. So we're going to have to add pi to whatever we get, because then it'll just bring us around. Or rather, I should say, we're going to have to minus pi, because we want to have a negative angle to show that we're going to have a negative angle because we're going this way. 0.64, and we're going to have to minus a pi. So it's going to equal, the actual angle is going to be negative 2.498. We'll just do that. for tan inverse, when we're doing this, if we're going to get an angle up in this first quadrant here, we've got quadrants 1, 2, 3, 4. If we're going to get something in 1 or 2 and we actually want it in 3 or 4, we're going to have to minus a pi. So that's something to keep in mind. I hope that video helped you with your studies, and I hope to see you in the next video.